CFA Level 1 Practice Questions. Learning Module, Parametric and Non-Parametric Tests of Independence. Topic: Tests concerning correlation. Maria Chen is analyzing the relationship between the monthly returns on Global Tech, Incorporated stock, and the monthly percentage change in the U.S. Consumer Price Index for Information Technology, CPIIT. Based on 120 observations, she calculates the sample correlation between Global Tech returns and CPIIT to be 0.1825. She wants to determine if this correlation is significantly different from zero. At the 5% significance level, the critical value for the test statistic is approximately 1.96. The statistical relationship between Global Tech and CPIIT is significant because the calculated test statistic is outside the bounds of the critical values for the test statistic. B, insignificant because the calculated test statistic is inside the bounds of the critical values for the test statistic. C, significant because the calculated test statistic has a lower absolute value than the critical value for the test statistic. An analyst computes the correlation between monthly returns on Brightwave Corp. stock and the monthly changes in the oil price index. Based on 200 observations, the sample correlation is negative 0.12. At the 5% significance level, the critical value for the test statistic is approximately plus or minus 1.96. The relationship between Brightwave returns and the oil price index is significant because the calculated test statistic exceeds the critical value. B, insignificant because the calculated test statistic does not exceed the critical value. C, significant because the correlation coefficient is negative. The t-statistic calculation follows the curriculum formula exactly. The calculated value 2.016 exceeds the critical value 1.96, placing it in the rejection region. This demonstrates that significance depends on both the correlation magnitude and sample size. The decision rule is clearly stated: reject H0 if t exceeds critical value. A small correlation, 0.1825, can become significant with large N because the test statistic numerator increases with square root of n minus 2. Option C is incorrect because it reverses the decision rule. Correlation tests use df equals n minus 2, while chi-square independence tests use df equals r minus 1 times c minus 1. The t-statistic formula is consistently applied. Significance requires the absolute t-statistic to exceed the critical value. The test statistic is calculated using the correlation formula. With r equals negative 0.12 and n equals 200, the test statistic approximately negative 1.70. Since t is less than 1.96, it falls inside the acceptance region. Therefore, the correlation is statistically insignificant. Option A is wrong because the test statistic does not exceed the critical value. Option C is wrong because the sign of the correlation, negative, does not determine significance. Significance depends on whether t is greater than critical value, not on the sign of r. Even with a large sample size, a weak correlation may still be insignificant. Correlation tests apply to continuous variables. Independence tests apply to categorical variables. Degrees of freedom for correlation test equals n minus 2. Decision rule: reject the null if t is greater than critical value. Topic: Tests of independence using contingency table data. An analyst is using a chi-square test of independence to determine if there's a relationship between a person's preferred social media platform, Facebook, Instagram, X, and their age group, 18 to 29, 30 to 49, 50 plus. Based on this scenario, which of the following statements is most accurate? A. The null hypothesis is that a person's preferred social media platform and their age group are dependent. B. The degrees of freedom for this test are 4. C. A very large test statistic would lead the analyst to conclude that there is no relationship between the two variables. An analyst constructs a contingency table to test the independence between investor risk tolerance, low, medium, high, very high, and preferred asset class, equities, bonds. The number of degrees of freedom for this test is E6, B3, C8. Which of the following is a property of the chi-square distribution used in a test of independence? A. It is symmetric with two tails. B. It is normally distributed with mean 0. C. It is right-skewed and only has a right-tailed rejection region. The null hypothesis in a chi-square test of independence is that the variables are independent, not dependent. Degrees of freedom are calculated as rows -1 times columns -1. With 3 age groups and 3 platforms, DF equals 3 minus 1 times 3 minus 1 equals 4. Large chi-square values reject H0, evidence of dependence. Correct answer: B. Degrees of freedom equals 4. Option A is wrong because H0 always states independence, not dependence. Option C is wrong because a large chi-square statistic means strong evidence of a relationship, not no relationship. The chi-square test is non-parametric, uses categorical data, and the rejection region is always on the right tail. Correlation tests apply to continuous variables. Independence tests apply to categorical variables. Degrees of freedom formulas differ. Correlation tests, DF equals N minus 2. Independence tests, DF equals R minus 1, C minus 1. Always subtract 1 from each dimension before multiplying. The problem defines 4 rows, R, for risk tolerance, and 2 columns, C, for asset classes. Applying the correct curriculum formula, R minus 1 times C minus 1 results in 4 minus 1 times 2 minus 1 equals 3. Rejection region. Because the test statistic is based on square differences, it is always non-negative, resulting in a one-sided right-tailed test. As sample size, N increases, the test power increases. Analysts must therefore distinguish between statistical and practical significance. Always subtract 1 from the count of categories in each dimension before multiplying to find degrees of freedom. R minus 1 times C minus 1 is the only correct standard for contingency tables. Unlike the normal or t-distributions, the chi-square is not symmetric. It starts at 0, and its shape is heavily influenced by the degrees of freedom. Because the test statistic is based on square differences, it can only be 0 or positive, resulting in a one-sided right-tailed rejection region. The formula ensures the calculated value cannot be negative because of the squared numerator. A larger test statistic indicates a greater deviation from independence, providing stronger evidence to reject the null hypothesis. Contrast with symmetric distributions. The chi-square is distinguished from the normal and t-distributions by being asymmetric and non-negative. For tests of independence, degrees of freedom is specifically R minus 1 times C minus 1, which dictates the specific critical value on the right tail of the distribution.